Welcome to today's explainer. Think of the Cambridge computer science examinations like the Olympic decathlon. It's an ultimate test of endurance, featuring 10 distinct disciplines and 10 unique challenges. You've got to master every single type of question they throw at you. Today, we are taking on one of the most notoriously tricky events in this decathlon, the BCS, the British Computer Society Professional Ethical Bodies topic, specifically for the 9618 syllabus, though these exact same foundational strategies apply directly to syllabus codes 0417, 0478, 0983, 0984, and 2010 as well. Our mission is simple. We are unlocking the exact, closely guarded strategies that examiners use to separate a standard B grade from that highly coveted, elusive A star. Look, picture this scenario. We've got a really complex, multi-part Cambridge past paper question on the screen right now. I want to introduce you to two very typical students taking this exact exam. On the left side, we have Alex. Now, Alex is a genuinely hard worker. They've spent hours studying, but Alex falls into a massive trap, overloading their answers with raw computer science facts. They just dump every single thing they've ever memorized about the BCS onto the page, but there is absolutely zero critical analysis. Then, on the right side, we have Sam. Sam knows the material, maybe even better than Alex, but Sam always rushes. Sam completely misses the specific command word requirements. They just glance right over whether the question asks them to state, describe, or evaluate, and look at the result. As you can see from the glaring red pen marks completely covering both of their answers, neither approach actually works. They are both bleeding marks. But don't worry, because today we are going to fix exactly that. Here is our ultimate playbook for today's session. We'll kick things off with the ACE difference. Then we'll dive into top examiner warnings, build out a procedural framework, tackle critical analysis, and finally, we'll wrap up with the life-saving method mark strategy. Let's jump right in. Section 1, the A difference. This is where we set the stage, because securing top marks requires moving way beyond superficial memorization and building deep conceptual architecture. I want you to look really closely at this quote. We pulled this straight from the official Cambridge Principal Examiner reports. Candidates referencing cross-topic connections achieve significantly higher marks. Let that really sink in for a second. The absolute secret to top marks isn't just knowing the BCS ethical principles in a vacuum, it's integrating them with entirely different areas of the syllabus. If you're given a scenario about a hospital database, an average student is just going to write, the developer has to keep the data private because the BCS says so. That's a C-grade answer. A top-tier A-star student is going to say, under the BCS duty of professional competence, the developer must ensure data privacy by implementing specific relational database security measures, such as hashing passwords and using parameterized queries to prevent SQL injection, ensuring total compliance with data protection legislation. Do you see the massive difference there? They built a bridge. They connected the theoretical ethics module directly to the highly technical database and security modules. That integration is what Cambridge demands. And this is where we need to introduce the PEAL framework. Point, evidence, explanation, link. Your point is the BCS ethical principle. Your evidence is the cross-topic technical detail, like the SQL injection I just mentioned. Your explanation is how they interact, and your link ties it right back to the question's specific context. This is how top students structure every single answer. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 2, Top Examiner Warnings. Now we are going to pivot and look at how to avoid the most predictable, agonizing errors students make year after year.
So, here's the million-dollar provocative question. Why do students actually lose marks? Why did Sam, who clearly knew the syllabus inside and out, end up with a C instead of an A star? It all comes down to a fundamental, catastrophic failure to decode the command words. Let's break down these computer science-specific assessment objectives. The examiners use highly deliberate words like identify, describe, explain, discuss, and evaluate. Each and every one of these requires a completely different cognitive load and a totally different answering structure. Sam rushed. Sam treated an evaluate question as if it was just an identify question. When Cambridge asks you to evaluate an ethical scenario, they are begging you to weigh the pros and cons, to look at both sides of an ethical dilemma, and to come to a heavily justified conclusion based squarely on the BCS framework. If you just list facts, or if you rush past that command word, you literally cap your grade. You lock yourself out of those higher band marks entirely. Let's break down the top 3 specific mistakes pulled straight from those examiner reports, and watch how we can transform these answers live. First up, answers are too vague. Examiners absolutely crave technical precision. If Alex writes, the system should be safe, Alex gets 0 marks. The red pen comes out. But if we guide Alex to rewrite this using our framework, it becomes, the system must undergo rigorous alpha and beta testing to ensure it meets the BCS requirement for professional competence before deployment. Boom. The red pen turns into a green checkmark. Second, forgetting boundary conditions and edge cases. In computer science, whether you are coding in Python or discussing BCS ethics, the extreme edges are where systems break down. If you're discussing the ethical deployment of an AI system, what happens at the boundary conditions of its training data? Failing to discuss these edge cases shows the examiner a lack of deep understanding. Third, and this is massive, answers ignore the specific context of the question. If the past paper scenario is about an autonomous self-driving car, your answer cannot be a generic, pre-memorized essay about software piracy. Every single point, every Peel paragraph you write must explicitly tie back to that self-driving car. This is the transformation. When you apply the Peel framework and respect the command words, you stop bleeding marks and start banking them. Section 3. The technical methodology. It is time to introduce the procedural scaffolding you need to tackle these complex questions effortlessly. Okay, let's walk step by step through this standardized sequence. Think of this as your computer science success blueprint. This procedural processing is the absolute key to algorithmic thinking in your exams. Step 1. Deconstruct the question. You literally take your pen, circle the command word, and underline the key entities. Step 2. Extract relevant data. What specific details about the software architecture or hardware constraints are actually provided in the prompt? Step 3. Select your analytical framework. Are you evaluating this based on the BCS duty to the public interest or their duty to the profession? Pick your lane. Step 4. Execute with clear notation. Plan your logic systematically before you write a single word of your final answer. Step 5. Present with correct terminology. This is non-negotiable. Never, ever use a layman's term when a precise computer science term exists. If a student writes, "The programmers should make sure the code is good so people don't get hurt," they fail Step 5. It should read, "To adhere to the BCS principle of public interest, the developer must implement robust error handling to prevent runtime crashes." That is algorithmic thinking applied to theoretical ethics. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Section 4. Framework for critical analysis. Let's move to the higher-order assessment objectives and construct a flawless, high-scoring comparative analysis. Welcome to our interactive workshop. I want you to be highly active here. Look at the stark contrast on the slide. On the left side, listing facts. This was Alex's original flawed approach. Its superficial breadth and incredibly weak reasoning. You can list 10 true things about the BCS, but if you don't connect them, your mark potential stays at around 30%. On the right side, comparative analysis. This is the A-star zone. You identify similarities and differences, you use comparative connectives like whereas or conversely, and you support everything with hard evidence. All right, let's test this out live. Challenge 1. Data scan. Look at the complex computer science data source on screen. I'm putting 60 seconds on the clock mentally right now. Scan it. What is the core trend? Are the ethical violations skewing towards data privacy or intellectual property? Got it? Good. Challenge 2. Find the flaw. I'm showing you a sample paragraph. The new software was fast, so the BCS guidelines were met, but the database wasn't encrypted. Spot the sentence losing marks? Right there. Saying the guidelines were met just because it's fast is a massive logical leap. The examiner's commentary would tear that apart for lacking justification. Challenge 3. Speed writing. You've got 30 seconds. In your head, draft one perfect Peel paragraph addressing that unencrypted database using the BCS duty of professional competence. Point, evidence, explanation, link. If you can do this under pressure, you're ready for the exam. And this brilliant breakdown right here illustrates exactly how we tie pure, hardcore coding concepts back into our ethical framework. When a BCS question asks you to evaluate a technical solution, you might be scratching your head thinking, why on earth are we talking about algorithms in an ethics question? Let me tell you why. Because writing horribly inefficient code has massive ethical implications. These 4 critical metrics, time complexity, space complexity, edge cases, and the effect on overall performance, they absolutely must be part of your justified recommendations. Imagine a developer writes a sorting algorithm with a terrible big O notation, like O of n squared time complexity, for a hospital's critical life support monitoring system. That is not just a minor coding error, that is a direct, blatant violation of the BCS duty to maintain professional competence and safeguard the public interest. If that system lags because of bad space complexity, it could literally mean life or death for a patient. By connecting Big O notation and algorithmic efficiency directly back to the BCS Code of Conduct, you are demonstrating that cross-topic mastery we talked about earlier. This is exactly what the principal examiners are begging to see.
Finally, Section 5, the method mark strategy. This is the third rule in our complete answering system, and it is your ultimate safety net.
I need you to pay very close attention to this because this is an urgent examiner alert. Show you're working. Method marks can and absolutely will save you when things go wrong. I literally cannot emphasize this golden rule enough. We call this the time management matrix. Do not ever skip steps on your paper. Even in theoretical questions or questions involving data interpretation or multi-step calculations related to ethical case studies, like calculating the storage requirements for secure backup facility, you must lay out your logical step-by-step process clearly on the page. Let's say you're doing a parity bit calculation to ensure secure data transmission under BCS guidelines. Even if your final calculated answer is completely wrong because you simply dropped a negative sign or misread a minor detail in the rush of the exam, displaying a clear, logical sequence guarantees you will pick up method marks. The examiners desperately want to reward your algorithmic thinking. If they can visibly see your brain working on the page, they will give you partial marks. If you just write down a wrong final answer with 0 working out, you get nothing. Write everything down.
So, we've reached the end, and the crucial point we leave you with is this provocative question. How will you apply this procedural framework to your next past paper? You've seen the complete system now. 1. Command word decoding. 2. The Peel framework application. 3. The time management matrix. You've seen how moving from vague, rushed answers to precise, cross-topic analytical masterpieces completely shifts the grading outcome. It is all about systemic analysis over rote memorization. When you sit down to write your next line of code or answer your next massive exam question, you have to ask yourself, are you just making the system function, or are you ethically engineering it to protect the public? The difference isn't just an A star on an exam, it's literally the future of our digital world. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.